This is A levels 9702, October, November 2024, paper 1-2. The grade thresholds are mentioned here. Starting with the question number 1, he says, which one is a physical quantity with respective unit as well? So, which is not one of them. So, mass is in grams, length measured in meters, charge is measured in coulombs, not in amperes. It's supposed to be current for amperes. So, and D for temperature, and then for Kelvin. So every option is right, but C is not, as asked in the question. Question number 2, he says, a small car travels in a town. You can imagine that the mass of a car could be around 800 to 1000 kilograms. And since it's traveling through a town, it cannot be moving at a high rate of speed. So it could be around 40 kilometers per hour or around 30 miles per hour. So when you convert this into meters per second, the velocity comes out as around 8 to 10 meters per second. Now, you will notice that if you apply the kinetic energy formula, which is half mv square, no matter which range of values you choose, reasonable estimates, of course, you would realize that your answer comes out with the 10 raised to power 4 factor, which is going to be this one. So he's made sure that all the estimates that you might take, where the range of values will land you in this power figure. So this is going to be option A. And the rest of them have a huge difference, so it's not possible. Question number 3, he says, a solid bar with a square cross-section area has a length this much, width this much. And since it's a square, then whatever is the width will also be counted as the breadth. These values are used for the calculator to calculate the percentage uncertainty in the volume. So, for volume, we know that we need to multiply all the lengths and all the measurements together. So, the length of this bar is given to us as 50 centimeters with plus minus 0.2 centimeters. So, the proper way of writing this down would be this, like this. So, 50 plus minus 0.2 centimeters, and it's a square. This dimension and this dimension with the square face will have the same measurement, will have the same value for length. That is 2 into 0.01. So 2.00 plus minus 0.01 centimeters. I'm going to write it in the shorter form here because I'm limited by space. These three quantities, if you multiply them together, you'll find volume. Now, since we're only supposed to find out the percentage error or percentage uncertainty, we don't have to calculate the volume per se itself. So the actual formula of this would have been like this: change in volume or error in volume divided by volume equals to change in all the, let's keep it as width divided by actual width plus, not plus minus, but plus, change in breadth divided by breadth plus error in length divided by length. And if you multiply all of this together with 100, then you actually get the percentage uncertainty. If you wanted absolute uncertainty, then of course you'll calculate the volume first by multiplying 50 with 2, multiplied by 2, since volume is calculated now. You'll bring this value to the other side, and then instead of multiplying with 100, you will multiply it with volume, and then you will find the absolute uncertainty. But since we are not doing that, we can leave out these calculations over here, and we just put in the values for this one. So this will be 0.01 divided by 2 plus 0.01 divided by 2 plus 0.2 divided by 50. And the bracket gets multiplied with 100. And your answer will come out as exactly 1.4%, which is option D. Now let's move to 4. This is one of the repeated questions, and it's an interesting question. So the acceleration in the early days, you can see, is 0. Over here, the acceleration is also 0. And at certain point, at around half time, the acceleration reaches its maximum value. Now, since all these graphs are velocity time graphs, we need to go back to the basic, you can say from memory or from logic, that velocity time graph and their gradients represent acceleration. So we just need to match the characteristic of acceleration with the appropriate gradient function or gradient or slope function in these graphs. So first of all, a graph that looks exactly the same would not be an option. That's a common misconception, or you can say I would be eliminating this option as the first because it's not possible this way. And then I would be eliminating option C because in the acceleration graph, we can see that if the object is accelerating and it's moving in a straight line, it's not possible that the object is going to slow down and stop at a certain point. And since it is a straight line, they're not moving in a circular motion. It's not possible that they would appear to us that they have stopped moving. So, and the object starts from rest, so the graph has to start from the origin. So I'm rejecting C because it believes that the object is going to stop at these 3 points. It will be stopped at this at the start, but it's not going to be stopping at any point soon in the middle of the journey. So I'm rejecting this option based on this. Now I'm confused between A and B. They're both representing similar trends as the acceleration graph. But there's a problem with option D. You see, if we look at the gradient keeps increasing, or the tangent keeps increasing. So if the gradient keeps increasing, keeps increasing. So the acceleration for this option D, or the graph for acceleration time for this option D, should have been something similar, either like this one, or either like a curved line upwards. The acceleration should also have increased with the passage of time. Again, we don't know this now, but I can assume that if the gradient and acceleration are always increasing, then the graph of acceleration time should have been or should have looked like this. But since it's not the case, I'm rejecting this option out of this idea. Now let's analyze option A, which is the right answer. Let's analyze it with the gradient. So the value of acceleration increases at first. So I can imagine that the gradient should be increasing. It achieves a maximum value at the center of its journey, around about here. And then the acceleration starts decreasing. If the acceleration is decreasing, then the gradient should also decrease. And this is what happens at the end of the journey. The gradient, the slope of the line, has started to decrease, which is why option A is the best answer to go forward. Question number 5, he says a ball falls. This is a very common repeated question. You can solve this by this logic that the gravitational potential energy, or the change in gravitational potential, is actually being converted into change in kinetic energy. So mgh equals to half mv squared. Now by the virtue of this equation, you can see that the mass is going to cancel out from both sides. So you will find that in some solutions, they have written this equation directly down as 2gh. This is where it comes from. So it's going to be a matter of just replacing the values now. So 2 into 9.81 multiplied by how high it was released from. So this is 0.4. So the velocity, don't forget to take the under root, please. So the velocity is going to come out as 2.8 meters per second, which is option B. You can use an equation of motion over here, which would be v square equals to u square plus 2as. Now, if you realize, since it was released from rest, the initial velocity component becomes 0. So you're left with v square equals to 2as, which is exactly this equation. If you take the under root to the side, this becomes v equals to under root 2as. S is the displacement, whereas h was the height. So since it is falling down, the height of the building actually becomes the displacement. The ball is actually going to follow through. So you can look at it from any perspective. Question number 6, he says that the ball is thrown horizontally off the building, and I've added an image how he assumes that this is going to happen. The air resistance is negligible, as in most questions it will be. Which statement about the motion of the ball is correct? So the rotation of the ball is always at right angles to the path of the ball. Now this, in terms of visualization, is a bit inaccurate. Why? Because the path of the ball gradually changes and becomes like this, whereas the gravitational acceleration always stays perpendicular to the ground or the Earth's surface, which is why we can't say all the way right angles. At the beginning, it was, but not at the end of the path. So that's why I am rejecting option A. Option A should be possible. Let's move on to option C. Let's zoom in a bit. Yes. So what do we have for option B? He says the ball follows a circular path. It never does. It is actually a parabolic path. This is again a piece of information. You see, projectile motions always follow a parabolic path. So B is also being rejected based on this idea. And also you will find this parabolic information in this regard, or in this statement, that there is a horizontal component and a vertical component of acceleration, be that in an electric field or be that in a gravitational field. They always produce a parabolic path. Now, option C says the ball has a constant acceleration, and this is one of the best answers you can say given in this situation. This looks like a good option. The ball's time in air is proportional to velocity at which the ball is thrown. Now, this looks like a confusing statement, but is there any truth to it? So let's try to analyze this in that regard. So we can apply equation motion, which is S equals to ut plus half at square. Now, we can see that the time of fall, as he mentions, the time is proportional to the velocity, is actually not proportional to velocity, is actually going to be equal to under root of 2s divided by a. And if you incline yourself towards this equation, v equals to u plus at, you would realize that it seems that velocity is proportional to time. But there is a problem. You see, you are dealing with the horizontal or vertical components. The horizontal component is not experiencing any acceleration, but the vertical one is. So by the end of it, the acceleration is actually in the direction of the gravity, right? So this equation does not settle in with the statement of the question that balls in is proportional to the velocity at which the ball is thrown, which was the vertical component. The horizontal component. Now, the horizontal component is not affected by gravity. Since it's not affected by gravity, it cannot control how long it stays in air. So how long it stays in air is actually controlled by the gravitational acceleration, or if it had a vertical component of velocity, which is why even if we use this equation for any component, the acceleration is not affecting the horizontal component, which is what he's trying to say. So we are rejecting this option based on this idea that is inclined towards commenting about horizontal component, which is not possible. So yes, C seems to be the best answer in the given circumstances. Question number 7, a very good answer, a very good question in terms of clearing out your concepts of momentum in terms of relative speed rule, which they have just recently started mentioning in the syllabus. Now he mentions that the collision is inelastic. The objects off together, and also one of the tricks is that if they are embedded together and they move and they start moving together, chances are they are going to be in an inelastic collision. But anyways, so assume that two objects are in a related system, okay, which means that there is no third force or third party involved in this collision, which accurately describes the possible values of total momentum. Now, since it's an inelastic collision, the kinetic energy before and after will not be the same. So since they have to be different, one option, option D, gets cancelled out based on this idea that they cannot be equal. They are equal for elastic collisions, but not for inelastic. So we reject this option. Okay, fine, that's good enough. But what about the order of energy? You see, since in elastic collision, the energy is being lost to the surroundings, so I can say that the kinetic energy before should be greater than the kinetic energy after the collision because energy will be lost. So kinetic energy should be greater before the collision. So based on this idea, I am rejecting option B because it says the energy before the collision was less and after the collision it somehow increased. That's now how it goes. It is supposed to be greater before because it is going to be lost to the surrounding. Now, the momentum itself, now since we are left with option A, momentum is always conserved if it's elastic or no matter if it is inelastic. So momentum before collision is x and the total momentum after collision is 2 is a wrong statement. It's wrong physics. It's never going to be like this. They're always going to be equal, be that elastic or inelastic. So the only situation that fulfills all of these statements, you see, these were also right. B, C, and D, they were also correct in terms of maintaining the momentum before and after, but they had other issues. That's why they have been rejected based on that. So the best answer in these circumstances will be option C. Question number 8, I've added some graphs for the explanation and testing what the options he has given us. So question number 8, he says, there's going to be a quantity on y-axis and one of them will be on x-axis. Which quantities could x and y represent? You can try all of them, and if you have had a lot of practice, you would realize that some of the options will be cancelled out immediately. So let's figure out if option A could be possible. So option A, let's try option A here. So if this is time, the y-axis represents acceleration, He describes falling vertically at a terminal velocity. When you're falling at terminal velocity, your acceleration is actually equal to 0. There is no acceleration. So for this graph, the actual line should have been close to 0. So I'm drawing it separately so that you can see it, but the actual answer should have been 0 if it had been option A. Let's try option B. Actually, B is the right answer. So let's try option C and D. So for option C, he says X is actually the distance moved and Y is the kinetic energy. So keep it as kinetic energy. Now, if the ball is moving at terminal velocity, and if I apply half mv square formula, the velocity has not changed from a long time because it is at terminal velocity. The value of velocity is not changing. So would the value of kinetic energy change? It wouldn't change. So although the distance would be increasing as it moves towards the Earth, the distance is increasing as it starts traveling down, but the value of kinetic energy will not be changing. Same thing happens with option D. This is the distance moved if it was released. The distance, it is actually going to keep moving down. So even in this case, the value of velocity would still be constant because it's at terminal velocity. It's not changing. Whatever, let's say 5 meters per second it is falling, it will maintain that until it hits the ground. These are the graphs for the rest of the options. And the best one is actually option B, time with height of the surface. And this one makes a lot of sense. You see, height above the surface or the distance the object is going to be moving while moving down keeps on increasing because that's the length of path the ball is covering while it moves down. In terms of the height, in terms of, let's redo this. So this is time. Time is moving on. Don't actually stop this. So, and this is the height above the surface, and that is going to decrease gradually. If it was still gaining speed, then it might have been like a curved option, like this one. But since it is moving at a constant speed, I can say that the rate of descent would also be constant. And its height, let's keep it as h, and this is time. So I can see this is distance time graph. And the gradient for distance time graph also represents speed, or in this case, velocity, because we know it's moving, we know the direction. So the speed should also be constant. So the gradient should also have been constant. So this option B fills most of the criteria, all the criteria that we can think of. Question number 9, he says, a ball horizontally with a speed of 4 collides with a wall, runs opposite direction. Now this is important, opposite direction. P2 point at the time, equation is 150 milliseconds. He wants to find you the force. So the very, very simple formula for force will be F equals to change in momentum divided by change in. And for momentum, I'm taking mass common on the outside because the mass of the ball has not changed, but the velocities have. So velocity in this case are going to be vector components. If we imagine that this was moving towards the right side with 4 meters per second, bounces off towards the left direction with 2.8 meters per second, I'll have to add a negative sign for this one. Now, since we're interested in the change, there will be a negative sign because of the simple English translation. Now, the final speed is negative 2.8. The initial speed was 4. You would realize that these numbers are going to get added together. Now, since we are not interested in the negative element or the negative of the answer, we can simply add them together because negative 2.8, negative 4 will simply add together due to arithmetic. And then divided by time will actually become 150 into 10 raised to the power minus 3 milliseconds because it is ms. So when you calculate this, you will find that this, or replace the values, this will actually be 2 into 2.8 plus 4 divided by 150 into 10 raised to the power minus 3. So the force in this case comes out exactly as 90.66 something newtons, which is going to become 91 in this case. Question number 10 has been a repeated question in the past. I've added where you can find the same question again with exactly the same value. So the problem or the trick in this question was how much energy is lost during the collision. So first, you were going to find out the kinetic energy before the collision happened. So simply half into 5,000 into v square, which is 2 square of the first trolley. Let's call this trolley A, and let's call this trolley B. And then the kinetic energy of trolley B, which would again be half m into 1 square. Now this comes out as 12,500 joules. Because of the exam pressure, you might think that this is the right answer, but no, it's not, because our question is about energy lost during this collision. This is the total energy before the collision. Now, they do mention that they join together and then move off. So we need to find out the velocity with which they are going to start moving in a certain direction when they get embedded together. So this will be momentum before collision, which is 5,000 into plus 2, because it's moving towards the right side. This will be negative, plus 5,000 into minus 1, because it's moving to the left side. So this will be momentum before the collision, and this has been equated to the momentum after collision, in which the mass will be added together. So it will be 5,000 plus 5,000, that's 10,000. Velocity is what I don't know. When you solve the whole system, your velocity comes out as 0.5 meters per second positive, which means that the whole system might be moving towards the right side with a velocity of 0.5 meters per second while they are embedded together. Now we find kinetic energy again, that is going to be after the collision, which is going to be half into 10,000, because they're moving together, into 0.5 square. Now this comes out as 1250 joules. Now be advised, this is the energy of the system that is still with them as they're moving away. This is the amount of energy they had originally. This is the amount of energy they have today. If you want to find how much was lost, you simply take the difference. So this will be 12,500 joules minus 1250 present amount. We are left with 11,250 joules being simply lost to the surroundings. So this will be option C. Question number 11, he says, which condition must apply for an object to be in equilibrium? So the object has a constant non-zero acceleration, not necessarily, and not always. Object is stationary, not always. Even when we are stationary, it's quite possible that many forces are acting on it, and there could be a force of rotation. So for equilibrium, there are two conditions. So the resultant force should be equal to 0, and the sum of all the resultant torques should be equal to 0. There are no forces. Object must apply. When it's about must, it means we need to consider all the forces, all the object experiencing is not a condition, is one of the cases, but not a condition. The resultant force acting on the object is 0. Yes, this is one of the conditions, but not entirely. There is one more condition, that is about torque. So option D fits the description in the best regard. Question number 12 is a common question. Is going to be asking about forces and the triangle of forces. He says there's going to be a wind with a force F, which we don't know yet, and this is a string with a tension component T. In this question, you didn't have to go through all the hassle of making the triangle. You see, if the kite is in equilibrium, we must have mentioned somewhere. So the kite is in equilibrium. Forces are not going to produce a net resultant force. So the loop rule is about pick any vector from the diagram and see if the loop completes itself. So T says go here, W says go here, F says go here. So I can say that the loop is completing in this option. This is my answer, but let's try the loop rule on the rest of the options. Pick any side, start from either T, F or W, it doesn't matter. So let's start from W. W says go here, F says go here. And then again, if I follow F along T, my answer. C, if T go here, F also follows it, but W doesn't follow the direction of T and F. Again, loop rule fails. Option D, again, loop rule fails with F and T following the same direction, but W does not. So D also fails. So my right answer is option A. But if you had to draw this diagram in terms of vector triangles, then simply use the head to tail method and you will get to the same answer. So you see, tension is supposed to be in this direction by the string. You join the next head with the weight, and if it is in equilibrium, then of course the tail of the last vector is joined, the head of the last vector is joined with the tail of the first vector. So when you join this, you find the resultant force by the wind, which is going to, of course, make sure that it doesn't move. So by T and W, the resultant force was in this direction. That was because of T and W. wind has to be in exactly opposite direction so that it stays in place, so that the result. And the best answer is going to be option A for that. Question number 13. A bit tricky, but don't worry. Whenever there are components, we can't resolve the components. So he's going to ask you, produce no moment P. So P is going to be our pivot for the whole situation, but I feel that it's like a torque question, is like a moment question, but in terms of torque. You see, there are exactly the same forces, and we do know that they're going to be a perpendicular distance between them, which is 7 plus 3. So I can make one equation. You can say that the clockwise torque is actually equal to 6 multiplied by 10, because for the equation of torque, we have force into distance. Any one of the force, if they're exactly the same, multiplied by the perpendicular distance between them, which will be 6 multiplied by 7 plus 3, 10. Now, the anti-clockwise torque is a bit tricky. You see, I can see that the force components are exactly given to me, and they are exactly the same. I can incline towards using the torque equation. So the force component will definitely be 5, but I'm not sure about the distance. The distance is a bit confusing. So I should choose perpendicular distance between the two forces, which should be the distance highlighted in this way. Only then I can use the torque formula. Or if you wanted to involve the force components, so that the force component looks like this, makes an angle of 90 degrees by using the 60-degree angle, that's completely up to you. You can do that as well. So let's assume that this distance between x and y is called d. I'm going to make the triangle separately. This is that distance, this is point x, and this is point y. I'm interested in this height, which is, let's say, height A, and this is, let's say, B. So let's fit in the angles first. This is going to be 90. I'm confused about the fact what angle should this be and what angle should this be. If I can figure out this angle, then it will be easy. So you see, if this is a straight line, and if this is a straight line, by simple geometry, if this is 60, then this should also be 60 degrees. The alternative angles in mathematics. And if this is 60, then this will be 30. That's your choice. You can choose any component. Since I'm interested in A and I'm looking for angle of 60 degrees, then it looks like that A will be equal to, or A can be calculated as D sine of 60. If you wanted B, B would have been calculated by D cos of 60, right? So the distance, or the perpendicular distance between them, is actually D sine of 60. And this is D, the length xy that they're looking for. Now, when you solve this, you will find out that the distance xy comes out as 13.85, which is definitely going to be option C, up to 2 significant figures. Again, I remind you, you can use the components of forces to make it with the angle of 90 degrees with the distance. Then the cos 60, the sine 60 component will come with the force. It's not with the distance. That's the only difference. Your choice. Question number 14, he says, we have the density of the block, we have the length, width, and breadth. He says, what's the maximum pressure? So pressure is equal to force over area. We can't change the force because force is being received or being produced by the weight of the object. But we can change how to orient, or in which orientation should we place the block so that it maximizes the pressure. If I want to increase the pressure, I need to reduce the area. So I will choose the smallest area in the divisor or in the denominator. But first we need to find the mass, to find the weight of the component. So that will be simply density equals to mass over volume, and volume taken over there. So this becomes 1.13 into 10 raised to the power 4, density given in the question, multiplied by volume. Since this is all in centimeters, be sure to make them, or to convert them into centimeters. So this will be 12 divided by 100 into 15 divided by 100 into 10 divided by 100. Alternatively, you could have written down as 12 into 10 raised to the power minus 2. That would also have been the right case. Equals to mass. Now the mass of this block comes out as 20.38 kilograms. So it's all coming together. So pressure equals to force, which is mg. So mass is 20.38 into g, which is 9.81, divided by the area. Now I'll have three options. I'll have three faces to choose from: phase 1, phase 2, and of course the base, which is phase 3. So how many areas or choices do I have? I have 12 multiplied by 15, I have 10 multiplied by 15, and I have 10 multiplied by 12. So since I'm looking for the smallest area for the maximum pressure, I will be going with 10 multiplied by 12, as this will give me the smallest answer of cross-sectional area. So this will be 12 divided by 100 and 10 divided by 100. Of course, we have to convert everything into standard format because the units is pascals, which means it should be Newton per meter square. The cross-section area should be in meter square as well. This will come out as a 16.7 into 10 raised to power 3 pascals. So this one is option D. Very simple question, straightforward with extra steps. This is also inspired from IGCSE, you can say, or O-level physics. What's the definition of power? So power is equal to energy divided by time, or work done divided by time. Let's see what fits the description. So it is work done per second, not really. Work done in unit time. In unit time, not really, because we're looking for per. Per means divided by. Work done in 1 second, not really. So the best option would be the formula that describes the formula, which is option D. Question number 16. He says that a model car travels at 12 meters per second, straight horizontal line. The input power is 800. The efficiency is 60%. What is the total resistive force? You see, the formula that we're going to use for this question is actually power equals to force into velocity. The formula is very simple, but the problem is how to apply this, how to use this. The application is the problem. You see, 800 watts is being provided by the engine, but only some of it actually goes to the tires, effectively. So first, let's figure out how much actual power is being received by the tires, or is actually being translating into the forward motion. So if I take the car as a machine, this is its input power, which is 800 watts, and this will be its useful output after the 60% problem. So you can simply multiply the power output, or to find the power output, by 0.6 multiplied by 800. We get that the output power should be around 480 watts. This is what the successful power or the useful power out of the engine is being received by the tires. And only this power is responsible for creating a certain velocity. Now, if it is moving at a constant speed, constant velocity, that means the forward force by the engine is actually should be equal to the backward force of the friction, drag, resistive components, and everything, and all the lot. And this is the true understanding of P equals to FV. It is moving at a constant speed because whatever engines could provide, whatever force the engine could provide, it is now being equally balanced by the resistive force. And this is an indirect way to find the resistive force. So in this moment, or at this point, I have access to 480 watts. I don't know how much force the engine is producing because I know it is going to be equal to the resistive force multiplied by the velocity that has to be maintained against this friction component, or against this friction. So F comes out as, in this case, 40 newtons. This will be 40 newtons. So now I know if this is the friction that the car is experiencing, I can guarantee that this is the force provided by the engine as well, because whatever it could do, it has already done to maintain the speed of 12 meters per second against some resistive components. And of course, the acceleration in this case is 0. Whatever the engine could do, the engine is already doing. Question number 17. Which statement represents the principle of conservation of energy? A good question in terms of the concept, but an easy one. Energy cannot be used faster than it is created. It can be in some cases, but not entirely true. The supply of energy is limited, so energy must be conserved. No. The total energy in a closed system is constant. Yes, this is much closer to the definition of conservation of energy. The total energy input to the system is equal to the... No, not always. This is for an efficiency of 100% system, but that's not always the case, or it's not always true. A barrel of mass 50 kg, again a common question. He says, what's the minimum work done to do this job? So the barrel ends up here. So the barrel has a mass of 50 kg. It has a vertical height of 1.6 meters. Now this is an indirect way of asking, can you find the gravitational potential energy or the change in gravitational potential energy? Because that is going to be the work done by any person standing at this point to push it above this line, especially also if it is frictionless. You see, if the barrel had some friction component, then definitely it would have to, or the person would have to make more effort apart from just producing gravitational potential energy. They would also have to add some component to compensate the friction. But since it's not the case, we can simply go ahead, straight away apply the formula, which is going to be 50 into G 9.81. And of course, the vertical height will be this one, which is 1.6. So when you multiply all of them together, this is going to very well come out as 784 joules, which is option C. Question number 19. What is the unit of stress? Now, stress is actually force over area. Now, force is MA and area is meter square. And this is actually kg, be advised. So this will be kg ms minus 2 divided by m square. This m goes to the top. This becomes kg m minus 1 s minus 2. So this is option A. Again, this is a very common question, but it should have been at the start in terms of homogeneity of the questions. But anyways, question number 20 says there are 3 wires of similar lengths, linear dimensions, which means their cross-section area, length, and everything else is different, but they are made from different materials, and definitely they will have different responses. Which statement is correct? The extension of P is approximately twice that of Q. Now, I don't agree with this statement per se. He says the extension. Now, the extension is actually going to come from strain. Strain is change in length divided by the original length. I can see that P, for any same value, let's choose for a simple value of stress. You see, if this is the amount of stress, P has a strain that is this much. Q has a strain that is this much. Q has a higher strain, which means Q has expanded more, has extended more. So it says the extension of P is approximately twice. No. P is extending less than Q. It should have been half that of Q. It's not experiencing that much strain. Its length is not changing as much as Q. Q is extending more. That is what strain is. So I don't agree with the statement. The ratio of Young modulus for P to Q is approximately 2. That is right. If we were to calculate stress over strain, the gradient of this equation, which would be, of course, Young modulus equal to stress over strain, or sigma over E epsilon, then definitely P would be double. The gradient of P is double that of Q, generally looking. I agree with this statement. For the strain less than 0.1, R obeys Hooke's law. Definitely it does, because it is a straight line. So it does. So question number, for this answer, option 2 and 3 only, C would be the best answer. Question number 21, he says, 4 solid steel rods gradually equally support a weight of 10 kilonewtons. Each rod has a length of this. Length is given and cross-sectional area is given. This is area, be advised. This is not radius or diameter. And the rod contract by, and this is your extension. So if this was our table, this question is confusing in this regard because it is contracting by 0.1. You might have imagined that this is probably hanging from somewhere, and as a result, he's carrying some load. No, it's the other way around. It's like a table, and the table has to support some weight on it. So these are the 4 pylons of that table, and they're supporting this 10 kilonewtons of weight, right? And we were supposed to find out the Young's modulus. So let's make the equation for Young's modulus, which is going to be E equals to FL over AE. And of course, this comes from force over area, stress over strain, which is extension over length. If you rearrange that, this is what it comes down to. So Young's modulus equals to the force component. Now the force is 10,000 newtons, but since there are 4 solid structures, it is going to be equally divided. So this will be 10,000 divided by 4 into the original length of this rod, which is 2 meters given to us over here, whole divided by the cross-sectional area. Now, this is a bit tricky. Be careful. He says it is 250 millimeters square. So we have to convert this into meter square. That's the main problem. So this will be 250 divided by, since it is millimeter square, this should be 1000 because 1 meter has 1000 millimeters. And since it's an area, I will put a square on top of this. This is my bracket for cross-sectional area sorted out. And then extension is 0.1 millimeters. So this will be 0.1. Either divide this with 1000 or simply add the prefix, which is 10 raised to power minus 3. I would advise you to calculate all of this in one go. If you think you're not comfortable with the calculator, then definitely go one by one with all of these things one by one in place. And you will find out that this is going to be very straightforward. The answer comes out as 2 × 10 raised to power 11 newtons per meter square, which is option B. Question number 22, he says the graph shows a spring varies with force and apply to it. Two areas P and Q are labeled. Which area represents the work done in stretching the spring? Stretching. You see, if you notice about this point, there is no force at this point, but there's still some length. It's non-zero, which means that the spring was still hanging, and this is its length being measured as L naught. This is L naught. When there is no force, there is no load on the spring. And the moment you added some load on the spring or the force, it definitely increased its length gradually, which is now probably L1. So let's say this is this point. So it goes to this point as L1 at a certain force F. So although generally it is the area under the graph, but we can't choose Q as one of the areas of work done because the length of the spring was already there. You didn't do that. There was no force. So the only area responsible for actually finding or calculating the work done in stretching the spring is area P. Question number 23. This is again a confusing question. They generally do give diagrams for this question, but this time he hasn't done that. He says a horizontal beam vertically polarized, which means it is actually going to go like this. It is moving in this direction. It is vertically polarized. With amplitude A, always be careful about the word amplitude because the equation that we have in our syllabus is actually with intensity. So I equals I naught cos square of theta. This is Malice's law. This is what's in the course. Now, we know that intensity is proportional to amplitude square. Can we change this equation? Yes, we can. So this will eventually look like if I change the amplitude or I change it to amplitude, this will be A, current amplitude, equals to A naught square, A original amplitude, with simply cos square theta. Since the question is dealing with amplitude, I will be using this equation and not this one. Now, you will realize it later what he has done. So, incident normally on a polarizing filter, the transmission axis of the filter is at an angle of 50 degrees to the vertical. So now it is vertically polarized and it is vertical with the angle. So the filter looks something like this. The filter is probably tilted. In comparison to the vertical, the filter is tilted like this. And the angle between the vertical and the tilt of the filter is 50 degrees. And this is the angle we're generally looking for. So A square, sorry, I missed that out. So amplitude square, current amplitude square equals to the original amplitude square in the cos square of 50. You will encounter another problem calculating this. I would advise you to calculate cos 50 first, then take its square. So let me show it to you. Let me solve it for you step by step. If you take cos 50, your answer is going to come out as 0.6427. Now you take its square. This becomes, this becomes 0.41317 and so on, of course. And this is still A naught square equals to A square. So this is one of the steps that you might do incorrectly. Take cos 50 first and then take its square to get the value. If you try to do this in one step on the calculator, I haven't been able to get it. It actually gives you a wrong answer. So this is the equation where we're standing right now. We're standing today. The question is about the amplitude of the beam as it passes through the filter. He says the original amplitude is A. So whatever A naught I'm writing down as is actually represented as A. So I'm going to write this down as AX square because this is what I'm expecting on the output. So this is A. And after the filter, let's call this AX being multiplied with 0.41317, this much. So since I'm interested in the amplitude, I will take this square to the other side and perform the under root function. So AX will now be equal to under root of A square multiplied with 0.41317. When you do that, this under root cancels out this square, and under root of 0.413 actually becomes 0.64. Let me just try this again. 0.6427A. A is now being written on this side, which is going to be option C. So I've done this question very gradually, step by step for you guys, because it adds a bit of confusion. I hope it's clear now. Question number 24, again, a repeated question from the past papers. There was another question, I think, in the past papers that was repeated previously. And I've added the years with it. It's okay, you can find the question. Yep. So question 24 is also one of the repeated questions in terms of graphs only. He says that it's a longitudinal wave, it's a sound wave, and the particles are shown in their positions. Air particles are shown. This is wave at one instant. First of all, figure out what these positions in terms of refraction, rarefaction, or compression are going to look like. This is the center of compression, and this is the center of rarefaction. This is also rarefaction. I can say that the length x is actually equal to the wavelength itself. Now he says that point Q is distance x from point P is fine, which graph shows the variation of displacement of the air particles with the distance from P along the wave. You see, it should show a complete wavelength, one complete wavelength. Since the x-axis represents distance, it should show one complete wavelength. I will be rejecting option A and B based on the same idea. It should be one complete wavelength. And we will, of course, get into the detail of particle motion as well, but first let's figure out this one. Now we have to make a choice between C and D. C and D both represent a wavelength in terms of simple graphical analysis. But is D an accurate representation? You see, at this point and at this point, it shows that the displacement is positive, which means that the particles should be moving. Do they move at their centers of rarefactions and center of compressions? They don't move. So the particle that is exactly center of rarefaction, which means that the particles on the right actually move towards this direction. Particles to the left move towards that direction. This particle, one individual particle, was left alone. And the same thing happens at Q. Particles move towards the left, particles move to the right. The particle at the position Q was left alone. It is stagnant, it is stationary on its own position in this instant in time. Same thing happens with compression. The particle at the very center is not moving. Particles from left and right are coming close to it, but the center of compression, the particle is not moving. Again, this is a picture in one moment of time. So option D gets cancelled out based on this idea that the particles at these locations shouldn't be moving. And this one says they are not. So the closest option we can get to is option C. Particles at the extreme positions are not moving. Yes, good. This is the rarefaction point. This is also the rarefaction point. This is P and this is Q. And somewhere in the center, we have no other point mentioned, but we can do that. And this was the center of compression. Now the particles are coming close to this point and the particles from this point are coming close to this point. So we can say that since the particles are coming close to point C or center of compression, they're moving towards the right side with a positive displacement. That's why the graph is in the positive side. On the other half, the particles are moving towards the left, which means that they should have a negative displacement, and this is what we see in the graph over here. So I hope that we understand that option C is the right answer. And again, I'm really sorry about this question, but I can't really help you with this. You have to memorize the whole electromagnetic spectrum. You have to memorize where the frequency or this frequency lies. This one lies in the ultraviolet region, and with a lower frequency, you will have to go a bit lower. And that is only visible light after ultraviolet. So this is option C for that answer. I can't really help you. You'll have to memorize from gamma up to radio, their ranges and their spectrums. Question number 26. A source of sound emits a wave of a constant frequency. Now, the question looks like a Doppler effect question, but let's see. The source moves at a constant speed in a straight line relative to the stationary observer. Which velocity moves at a constant speed, straight line relative to the stationary observer? Okay. Smallest observed frequency. Now, if you're looking to decrease the frequency or observed frequency, the first thing that you have to understand is that the object should be moving away from the observer. So I will be choosing option A or B. And if you want to make the small it's going to be f naught into speed of sound divided by speed of sound plus the speed of object. If I want this to be the smallest number, then the denominator should be higher. And the only way I can do that is using a larger value of the speed of the object. Instead of 5, I would use 10. If I choose a larger number, the whole denominator becomes a larger number. This number divided by a larger number, of course, will give you a smaller answer, multiplied by the standard frequency, again giving you a smaller answer. That is why we're going to choose option B. First decision was it should be moving away from the observer to decrease the frequency. The second decision was to choose a larger value of the velocity. Question number 27. Again, based on memory, he says, what could be the time-based setting of the CRO? So he says frequency per division. No, it's not frequency per division. Number of divisions on the screen per unit frequency. Not really. So the number of divisions on screen per unit time. Nope. The time per division on the screen. Yes, this is the right answer. But let me show you by zooming into an image of the CRO. If you can take this from the book as well. Notice that for the time division, that is over here, let me choose simpler, smaller. So notice for the time division over here, what's written actually. So this is time divided by div. Div is, let me rewrite this. This is time divided by div. And all these readings on this dial are actually represented in a similar fashion. So this, let's say if you choose 50 value, this would be 50 milliseconds per div, which means that one box along the x-axis represents 50 milliseconds, no matter where you count it from. So it's actually time divided by div or division. So that is what we represent here. It's time divided by division. That is why we chose option D. Question number 28. What happens when two waves superimpose or superpose at a single point? Their amplitudes are added together. Now, there is going to be an addition function. So that bit is right. Their frequencies don't get added together. Their velocities don't add together. Their amplitudes or displacement get added together. Now I have to choose between A and B. Which one would be the best option? You see, it is going to be displacements. Why? Amplitude is a specific displacement when the displacement is maximum. So are only these points adding together to produce a superposition result? No. It's a matter of vocabulary. It's a matter of problem with the vocabulary. The displacement means that all instantaneous points, every single point on the wave, this one, all these points are going to get added together with another wave, probably with a different phase of its life. They are going to be instantaneously added by every single point. And they are displacements. They are not amplitudes. Amplitude is a single point. We are not looking to add a single point. We're looking to add the whole wave. That's going to be option B. 29 is a bit tricky in terms of its length of thought. So electromagnetic is diffracted, passes through a single slit. The width of the slit is larger than the wavelength of the wave, which means that if this is the slit and this is the gap, the wave that is coming towards the slit, this is the wavelength, and the gap width is much larger than the wave itself, or the wavelength of the wave. This is what he means by that. Which change will decrease the amount of diffraction? We want to decrease the effect of diffraction. So how can we do that? So a couple of pointers before moving on to the question. Diffraction, or the effect of diffraction, or the bending, increases with the wavelength. And diffraction is inversely proportional to the gap width. If you decrease the gap width, diffraction or bending increases, which means, of course, there is going to be a limit to that, while the gap width is not smaller than the wavelength itself. So, but we're not interested in the gap width because we're not changing that. We are actually interested in the wavelength or the frequency part of the wave. So, V equals to F lambda. Now, since it's an electromagnetic wave, the speed of the wave will be constant. It's not going to change. Plus, if the source is introducing with a certain speed, it could be in a water wave, could be sound wave, the speed is the only constant variable between them, right? So if in terms of decrease of width of the slit, we're not looking to do that. We want to decrease the amount of, if we decrease the gap, it increases the bending. We can't choose that option. Increase the wavelength of the wave. Let's try to discuss that. So we want to decrease the effect of diffraction, which means we want, or we can decrease the wavelength. So if I wanted to decrease the wavelength, then what has to increase? Frequency has to increase in that regard. Not really. So let's look at the question again. If we test option A, it says decrease the frequency. According to V equals to F lambda, if we decrease the frequency, wavelength has to increase. So I'm rejecting this option based on this idea. He says, and again, increase the wavelength. If we increase the diffraction effect or the bending effect increases, so we're rejecting this option as well. Let's try to think about option B. Now, by elimination, we reached the conclusion that B should be the right answer, but let's check B on its own individual merit. Is that what we're looking for? Kind of like we are. So F is actually 1 over T. So if we decrease the time period, the whole factor, which is the frequency, increases. And the wavelength would have to decrease. This is what we're looking for. We want to decrease the wavelength because the velocity is constant. It's not changing. That's why there's going to be a back and forth between frequency and wavelength. So we want to do that. We want to decrease the wavelength so that the effect of diffraction decreases as mentioned in the question. That's why we're going with option B. Question number 30. Diagram shows, okay, so it's the fourth order. So N will be equal to 4. Theta is equal to 53. And he says we want to find the wavelength. Now, it's a very simple question, straightforward. So diffraction grating N lambda equals to D sine theta. So N is 4. Lambda is what we're looking to find out. D is given to me as this. Is 2.7 into 10 raised to the power minus 6. And sine theta is going to be sine into 53. Now, when you find lambda, this is going to, again, be careful about the arithmetic. When you solve it directly, this comes out as 5.39 into 10 raised to the power minus 7 meters, which is definitely option B. Question number 31, a repeated question at this location. You can find this and this variant as well. He says, find the frequency. I'm going to dive straight into the question. So this is a stationary wave set up in the tube. We can see that a node will be formed at the closed end and an antinode formed at an open end. This is not a part of the question, just added this for you. So if you look at the wave actually forms like this. So there are going to be 1.5 waves in a space of 30 centimeters. So I can say that if this is lambda by 2, this is lambda by 2, and this is also lambda by 2, this section of the wave, this much, I can simply count them and say that 1.5 wavelength are actually being covered in 30 centimeters. So one wavelength should be equal to 20 centimeters. Then it's a matter of using V equals to F lambda. Speed is given as 330. F is what we want to find out. Lambda is 20. Be careful about converting this into meters. Frequency comes out as 1650 hertz exact. Right? Okay. Now, the current in the resistor for a short interval time, there is a current. Which statement about the total charge that passes through the resistor is correct? You will find this topic's answer in this point in your syllabus. Topic 9, 9.1, point number 2, the charges are quantized. So it can take any value. No, it cannot. It cannot take any value. It is an integer multiple of an elementary charge. This is the most appropriate answer. It is the elementary charge, not always, because there are many charges flowing, so it cannot be just one charge. And that elementary charge's value is 1.6 into 10 to the power minus 19 coulombs. It is a rate of flow of current. No, it is always a rate of flow of charge per se of the definition. There is no such thing as rate of flow of current. Rate of flow of charge is the main thing for current. So by the essence of definition, D was rejected. It is not always the elementary charge, so B would be the right answer. Question number 33, you will find that question number 33 is repeated in these instant in past papers as well. You can go back and check. So potential difference across a filament lamp is slowly raised from 0 to its normal operating value, and we know for a filament lamp the resistance increases as it gets heated up. So which graph represents V and I? So C is not possible because it's against Ohm's law. You see, if you increase voltage, the current does not decrease. The change in current decreases, which means the current is increasing but not as progressively. Question number D looks like the graph of a diode per se, not exactly the filament lamp. And B is for an ohmic conductor which follows Ohm's law perfectly. But filament lamps don't follow Ohm's law. So option A is the right answer, and you will find the same answer in these options as well. It is always like this one. But why is it this one? So you keep on increasing the voltage. You are increasing the voltage, but you can observe that the current, as much as it increased in the first half, it's not increasing exactly in the similar fashion in the last half. And the reason for that is that the temperature of the filament lamp increases, it glows, and its resistance increases. Since its resistance increases, no matter how much voltage you start to provide it, no matter how much energy you provide it, the current does not increase, or it does not translate into increasing current according to Ohm's law, which was this one. Question number 34, an electric current of 12 amperes is going through a wire of 0.3.5 meters. There's a velocity given. How many free electrons? So let's try to find this out. So this will be first, speed equals the distance over time. Speed is 5 into 10 to the power minus 4. Distance is 0.35. Let's see how much time they spent in this length of wire. So the time they spent in this length of wire was 700 seconds, quite a long time. And then we have I equals to Q by T. So current was to the side, we can find Q. Q comes out as 8400 coulombs, which is a lot of charge. And we want to find the number of electrons, so we'll have to divide this with elementary charge, which is 1.6 into 10 to the power minus 19. So then we find the number of electrons that might have flown, that might have moved through this, which is going to come out as 5.25 into 10 to the power 22, which is option B. 35 is very easy and very straightforward if you know the rules of resistances. He says combined resistance of 100 ohms. I'm going to do this for all options so you can have an idea. So you see, when you find two resistors in parallel, you can either use 1 over 100 plus 1 over 50 equals to 1 over RT, or you can use the formula RT equals to product over their sum. This is a shortcut. Of course, it comes from the formula of the parallel resistances, but it only is only good for two resistors. So 100 multiplied by 50 divided by 100 plus 50, whatever answer it gives you, it will be 33 approximately ohms. So the combination of both of them is equal to 33 ohms. In series with 100, this will be 133 ohms. We're looking for 100 as in the question. In B, you can apply the same for this parallel combination as product over sum, or you can go for an even smaller shortcut. If you find that there are two resistors exactly the same in parallel combination, the combined resistance will actually be half of one of them. So this is going to be 50 plus 50, this becomes 100. If you're not fully satisfied with this statement, then you can definitely go ahead and use 1 over 100 plus 1 over 100 equals to 1 over RT. You can definitely use this equation, or use this one, product over sum, which is 100 multiplied by 100 divided by 100 plus 100. You will get 50. And this is equally true for other than 100. And in C, unfortunately, there is no shortcut. You'll have to use 1 over 100 plus 1 over 100 plus 1 over 50 equals to 1 over RT. I would advise you to put this all in a calculator once in one go, and then just raise this to 1 over raised to power minus 1. This will do the reciprocal for you, and this will come out as 25 ohms. Now we have option D. This becomes 250 ohms. So the 100 ohm resistor is only option B, circuit B. Question number 36, taken directly from the Kirchhoff laws. If you notice, it's point number 1 and point number 2 in 10.2, conservation of charge and conservation of energy. So I can't really help you with this. You have to memorize it. Question number 37, a cell with an electromotive force of 1.5, a current of 0.26, resistance of 5 ohms. What is the internal resistance? So you will find this in point number 5, 10.1 in your syllabus. But what is it trying to say? So it says that there is a battery of 1.5 volts, 1.5 EMF, there is an internal resistance, and there is an external resistance of 5 ohms. There is a current in the battery of 0.26 amperes. How much resistance is the internal resistance, small r, going to consume? Or what is the value of the internal resistance? So you can see that the EMF is actually going to divide into the internal resistance and the external resistance. The equation that represents that is actually equal to this one. EMF was supposed to be equal to IV, only the external voltage. But since it is not only limited to this one, IR, but since it is not only limited to that resistor, I have to add both resistors in series now. So with my external resistor plus the internal resistor. Now the EMF is 1.5 equals to current is 0.26 into R is 5 plus small r, some voltage consumed by the other element. You can do this by parts as well. What you could have done is 0.26 multiplied by 5. This will be the voltage of this resistor. Then subtract 1.5 with this value of voltage that you found and use that answer equals to IR for the internal resistor. You could have done that as well. But this one actually solves it in a single step. So 0.26 divided by, so taken to your side, 1.5 divided by 0.26. And then you take this number on the other side to subtract it. So small r comes out as 0.7692 ohms, which is 0.77, option D. Question number 38, which is not a quark flavor? You can see these are the quarks that are in your syllabus, that are in your course. Which one do you think is not one of them? It's a meson. How many quarks are there in the nucleus of hydrogen 3-1? So first we have protons and neutrons. We have one proton in this hydrogen, which is made of up, up, down. And we have two neutrons, which are made of up, down, down. So these are 2. So 1 plus 1 into 2 becomes 4, plus 1 becomes 5. We're going to have 5 down quarks. Question number 40. Isotope of boron decays by beta positive emission. Again, if you go to the syllabus 11.1, point number 9, an electron neutrino is a product of beta positive decay. So it should be an electron neutrino. Full word in marking schemes would be an electron neutrino or electron antineutrino, but you can simply write down neutrino as well. They are accepted as the correct answers. I hope you learned something. That is all for today.